Hi friends, let us now discuss about the repetitive DNA. Okay, so now we know that it is these repetitive DNA that are being used for DNA fingerprinting as probes. Let us see what are these repetitive DNA. Okay. This repetitive DNA is a part of non-coding DNA. It's a part of non-coding sequences of DNA. Number one. So as we have already discussed, the DNA is majorly made up of non-coding sequences and very less amount of DNA is having the coding regions, right? Again, within this non-coding sequence, majority of the non-coding sequences are made up of repetitive DNA. It is made up of repetitive DNA, majority. Okay. Now, why the name repetitive DNA? Because this particular DNA is made up of repeating sequences, right? This particular DNA is made up of repeating sequence of DNA. Means a small portion of DNA sequence is repeated for n number of times. A small stretch of DNA is repeated again and again and again for n number of times. That is the reason it got this name repetitive DNA. Okay? Well, first of all, if we want to make use of this repetitive DNA as probes for DNA fingerprinting, we have been using them as probes for DNA fingerprinting, right? Let us first know how to obtain them, and then we'll talk about the size of these fragments. So why have we chosen them to use as a probes is because of their suitability in terms of their size. Okay, so but before getting into the details of the size, let us first talk about how to obtain the repetitive DNA. Well, so when we are actually going for isolation of DNA, what is the technique that we have been using? Well, it is the density gradient centrifugation, right? Density gradient centrifugation. In this technique, the material is isolated based on their densities, right? So when you take a whole cell, subject it for cell disruption. So the very first step is tear open the cell, right? Let us first disrupt the cell. Collect everything into it and then go for DNA isolation. Using the density gradient ultracentrifuge, you're going for isolation of DNA, right? So when you do this, you are getting two bands of DNA. Every time you're performing the isolation, you're getting two bands of DNA majorly most of the DNA is isolated as one big band here, and some of the DNA is getting isolated as thinner bands. Okay, so when you are isolating the DNA using density gradient centrifugation, in spite of the DNA being one whole entity, the DNA got separated into different bands. Bulk of the DNA got separated into one thick band. We are calling this as the bulk DNA, bulk band. And rest of the DNA that got separated into small bands, we are calling this as the satellite DNA. Satellite DNA. So why the name satellite? Because this portion of DNA got separated from the major part of the DNA. Bulk band consists of the majority of the DNA. Satellite DNA is the part of DNA that got separated from the major portion of the DNA. So it got the name satellite DNA. Now when you analyze the satellite DNA, we observed that their densities are a bit different from the bulk bands because they are made up of repetitive sequences or the repetitive DNA, right? So if we want to obtain the repetitive DNA, take the DNA, put it in an ultracentrifuge, density gradient ultracentrifugation, and now collect the separated bands, that the narrow bands that we get here, separated bands, which are called as the satellite DNA, which is actually containing the repetitive DNA. Clear? Yes. So these repetitive DNA is further classified, is categorized into different parts. Let us talk about the repetitive DNA now. So now we know what is this repetitive DNA, where is it located, how to isolate it first of all. Now again, within this repetitive DNA, which portion of the repetitive DNA is being used as probes? Let us talk about this. This repetitive DNA has been classified into different classes. We don't want to talk about all the classes, but what is the criteria for classification? It has been classified based on a criteria. So what is the criteria? The criteria is, number 1, base composition. Number 2, length of the repeat. Length of the repeating unit, whether it is 10 base pairs or 10-20 base pairs or whatever it is. Third one is number of times it is repeated. Okay, so this is the criteria based on which the repetitive DNA has been classified. So we have different classes of repetitive DNA, out of which we are making use of only the mini satellites. So actually in our textbook he told us that there are 2 types of satellite DNA. One is the mini satellite and the micro satellite. And the mini satellites. But then micro satellites are too small, so we are not using them in DNA fingerprinting. They are of a smaller size, less than 10 base pairs in length, whatever it is. So we are not using them for DNA fingerprinting. DNA fingerprinting. Whereas it is this mini satellite that we have been using for DNA fingerprinting. The mini satellites, the size ranges between anything between 100 base pairs to 20,000 base pairs. Okay, so this is useful for our technique. Okay, now let us talk about the mini satellites. Okay, I hope this is clear now.